These are notes on different types of models. So this year in science, we're going to use a lot of different types of models. And there's two really main types of models that we talk about and that we use. One of them is going to be pretty familiar to you, and then the other one might be kind of new. So the purpose or the objective of these notes is to learn the different types of models and how they apply to science. So by the end of these notes, you should be able to define and recognize different types of models, give examples of different types of models, and match different examples to the model type. So one type of model is called a physical model. This is a larger or smaller representation of an actual object. So it's basically blowing something up larger than so that you would be able to see it, or taking something that's too large to completely see and making it a lot smaller so that you can see it. So one example of a physical model is a dinosaur model, right? So that's going to be too large to kind of take in all at once, so you make something a lot smaller. It's also something that not a lot of us have access to, like not a lot of us have actual dinosaur skeletons lying around in our backyard, so if we want to see something, we have to see a model of it. It's not the real thing, but it represents the real thing, and if it's done properly, then you should be able to see all of the right parts, right? So if you wanted to know this is a Tyrannosaurus Rex, how many ribs a Tyrannosaurus Rex had, you could count the number of ribs in here, and you should get a good sense of what an actual Tyrannosaurus Rex has. Similarly, it could be something that's too small to see, or too small to see maybe without a microscope. We can actually see cells without a microscope, so you'd want to blow it up a lot larger. And so this, again, it's a physical model. It represents an actual object, and you can see the different parts. So like in the middle here, this is what we call the cell nucleus. These kind of pink things are what we call mitochondria. The blue part around the outside is a cell membrane. And so those are all the different parts of a cell. You could also have, if you're an architect, you might make a model of a building that you're going to make. So you make everything exactly how it's supposed to be in the building to scale, meaning each room is the size it would be if you made it the correct size. So that would also be a physical model. That's where you would shrink it down. And then anything, again, that's too small, you could also have a plant cell, something like that, that you could make a physical model of. So lots of different types of models. And that's often what we think of when I say a model. People think something physical. So I think most of us will think of physical model. But there's another kind of model. There is a conceptual model. And that's a way of representing a system to explain how it works and make predictions. So first of all, there's a couple words in here that we might want to define. So one is system. A system is a number of parts working together. So that might be something you want to write down. That even though that's not on the note-taking guide. So looking at how different parts working together work and using it to make predictions. So trying to predict what could happen in the future, or if we changed one part of the model, how could that change things? So this is a little different, and we're actually going to be working a lot with conceptual models. So one example of that is a weather report. So the way meteorologists predict the weather is they look at what they can see. Okay, I see clouds coming from this direction. I see that the air pressure is dropping. I see that someplace to the west of us is really cold right now. So I'm going to put all that into my model of what I know. I know how air pressure and temperature and clouds work together, and I'm going to make a prediction. And this is actually the prediction for the rest of the week through the weekend. It may or may not be completely right. It is a prediction, but it is based on what we know of how different parts of the weather work together. Another example is a model of the atom. Now you might think that a model of the atom is like a physical model, except that we can't actually see an atom. We just have done a lot of experiments on it, so we know what kind of parts it has. We know an atom, and atoms, remember, make up stuff. So we know it has positive particles and negative particles and particles that aren't positive or negative. We know there's a big part in the middle. We know there's a lot of empty space. But this is actually a really good example of showing how the model of the atom has changed over time. So maybe some of you have seen this model here. This is called the Bohr model, with something in the middle and then things orbiting around outside. This is actually a better example, but it's harder to understand. This is even more up to date because as we learn more, sometimes our models change a little bit. So that's a conceptual model. So now what I want you to do is pause the video in a second, and I want you to match the example to the model. So we have a map and studying plays from an opposing team, and tell me which one's the physical model and which one's the conceptual model. So go ahead and pause it and do that. Okay, so what you should have is that the map is the physical model, right? A map is a smaller version of what actually exists so that we can see it more easily. Whereas studying plays from an opposing team, like say you're playing somebody in soccer, you might want to study what that soccer team has done against other teams to form a model so that you know, like, when they're in this situation, they usually do this, and that can help you predict how to play against them. It may not work out. They may do something different, but you can develop a model for how those players work. So if you have questions, you are welcome to add them onto Schoology in the comment section, or you can write them down on your note-taking guide or in your notebook and ask them tomorrow. And we will go over these notes in class. And these are due Monday. Have a good night.